Assalamualaikum everyone. We are Group 2 from CDCS 248-6A2. Today, we will present our project titled Road Maintenance Route Optimization in Banting using the Chinese postman problem. The maintenance vehicle needs to travel through every road in their assigned area. If the road is not planned efficiently, it leads to unnecessary travelling distance, higher fuel consumption, increased operational costs and more carbon emission. To solve this issue, we apply the Chinese postman problem, a graph theory technique that determines the shortest possible closed road that cover every road at least once. Before we begin, let us introduce our group members. Our project was completed by Daniel Haziq bin Sulaiman, Anik Nazhan bin Abdul Jalil, Muhammad Irhan bin Muhammad Said, Daniel Jasrizal bin Razali. Each member contribute to different parts of their project, including data collection, graph modeling, algorithm implementation, analysis, and report preparation. Now, let us begin with the introduction. Road maintenance plays an important role in ensuring safe and efficient transportation. However, when maintenance vehicles follow inefficient roads, they consume more fuel, require more travelling time, increase operational costs, and contribute to higher carbon emission. Graph theory provides an effective mathematical approach to model road networks. In this project, locations are represented as vertices, while roads are represented as wedge edges. We apply the Chinese postman problem, or CPP, because it finds the shortest closed road that travels every road at least once, making it highly suitable for road maintenance operation. Our study area is located in Banting and Jugra, Selangor, as shown on the map. For the problem modeling stage, we first selected 10 important locations within the Banting and Jugra road network. Each location was represented as a vertex label from A to J. The roads connecting these locations were represented as weighted edges, where each weight corresponds to the actual road distance. All distance were obtained using Google Maps to ensure that the graph accurately represents the real road network. This graph model serves as the foundation for applying the Chinese postman problem in the next stage.
Next, this slide presents the graph representation of the selected road maintenance in Banting and Jugra. The actual road network was modeled as a weighted undirected graph where each location is represented by a vertex labeled from A to J, while the roads are connecting the location are represented as weighted edge. The weights on each edge indicate the actual road distances in kilometers obtained from Google Maps. In addition, the agency metric records all direct connection between the selected location. This graph representation serves as the mathematical foundation for applying the Chinese postman problem to determine the optimal road maintenance route. After the road network was successfully represented as a weighted graph, the next step was to implement the optimization algorithm using the Python. The Chinese postman problem was implemented using Python with the NetworkX library in Google Colab. First, the weighted graph was created based on the collected road network data. Next, the degree of each vertex was calculated to identify the odd degree vertices in the network. After that, the shortest path between the odd vertices were computed, followed by the minimum weight matching process to determine the additional path required. The graph was then converted into an Eulerian graph, allowing an Euler circuit to be generated. Finally, the algorithm produced the optimal closed maintenance route that covers every road segment while minimizing the total travelling distance. Once the algorithm was implemented, the degree analysis and minimum weight matching result were obtained, which will be presented in the next slide.
Next, I will explain the degree analysis and minimum weight matching process. The original road network consists of 10 vertices and 14 weighted edges with a total road distance of 21.2 kilometers. The first step in the Chinese postman problem is to calculate the degree of every vertex. From the analysis, we found that 6 vertices have odd degrees, namely C, D, E, G, H, and J. Any Eulerian graph requires every vertex to have an even degree. Therefore, these odd degree vertices must be paired before an Eulerian circuit can be generated. Using Python and the Network X library, the algorithm performs minimum weighted matching to determine the best pairing with the smallest additional distance. The selected pairs are C to D with a distance of 0.85 km, E to J with 1.5 km, and G to H with 1.95 km. These pairings produce the minimum additional distance of only 4.3 km, making them the most efficient solution. This additional distance represents the road segment that need to be traversed again so that all vertices become even. After obtaining the minimum weight matching, the selected road segments were duplicated. The duplicated paths are C to D, E to J, and the shortest path between G and H. After duplicating this path, every vertex in the network has an even degree. This successfully converts the original graph into an Eulerian graph. An Eulerian graph allows an Eulerian circuit to be generated, which means the maintenance vehicle can start and end at the same location while covering every road at least once. As a result, the optimized maintenance route is obtained with a final total distance of 25.5 kilometers, which includes the original road distance of 21.2 kilometers and the additional 4.3 kilometers. This demonstrates that the Chinese postman problem is able to optimize the maintenance route while minimizing unnecessary travel.
Now, I will present the result and discussion of our Chinese postman problem or CPP analysis. Based on our calculations, the original road network distance is 21.20 kilometers. However, because some road segments must be travelled more than once to form a Eulerian circuit, an additional distance of 4.30 kilometers is required. This gives a total travelling distance of 25.50 kilometers. By using Python, we successfully generated the optimal maintenance road, and the results confirmed that every road segment is covered at least once, which satisfies the main objective of the Chinese postman problem. The Python output also matched our manual calculations, showing that our solution is accurate and reliable. Moving on to the discussion, our findings show that the Chinese postman problem is an effective method for optimizing maintenance roads. By selecting the minimum additional distance, the route becomes more efficient while still ensuring complete coverage of all roads. This optimization provides several important benefits. First, it reduces unnecessary travel, allowing maintenance vehicles to avoid excessive repeated roads. Second, it lowers fuel consumption, which helps reduce operating expenses. It also reduces carbon emissions, making the roads more environmentally friendly. Overall, these improvements contribute to lower operational costs for organizations responsible for road maintenance. Finally, this approach is highly suitable for real-world applications such as street cleaning, waste collection, and utility inspection, where every road must be visited while keeping travel distance as short as possible. To conclude, our project successfully modeled the Banting Road Network as a weighted graph and applied the Chinese postman problem using Python to determine the most efficient maintenance route. From our analysis, we generated the shortest closest route with a final optimized distance of 25.50 kilometers. This shows that graph theory is not only a mathematical concept but also a practical solution for solving real-world road optimization problems. Overall, this project demonstrates how optimization technique can improve the efficiency of road maintenance operation, reduce travel distance, and support more sustainable urban infrastructure management. That's all from us. Thank you.